Meet Marcus. He just got his statistics homework back, and there's a big red circle around the words Interquartile Range. He has no idea what that means, and honestly, it sounds kind of scary. But here's the thing. Quartiles and IQR are actually one of the coolest tools in all of math. They tell you how spread out your data really is. By the end of this video, Marcus and you will be reading datasets like a pro. Let's go. So Marcus stares at his homework and reads the word again, quartile. You know what's hiding inside that word? Quarter. And a quarter means 1/4. So quartiles split your data into 4 equal parts. Imagine cutting a sandwich into 4 equal pieces. Each piece is a quarter. When we arrange data from smallest to largest and find the 3 dividing points, those are Q1, Q2, and Q3. And here's a fun fact. Q2 is just median, which you probably already know. Okay, Marcus, here's your game plan. 4 simple steps. First, always sort your data from smallest to largest. Skipping the step is the #1 mistake students make. Step 2, find the median of the whole dataset. That's Q2. Step 3, look only at the lower half of the data and find its median. That's Q1. Now, here's the part Marcus was so confused about, the interquartile range, or IQR. It sounds fancy, but the formula is beautifully simple. IQR equals Q3 minus Q1. That's it. The IQR tells us how spread out the middle 50% of our data is. Think of it like focusing on the typical scores and ignoring the outliers, those weird extreme values that throw everything off. The IQR is super useful in real life, from analyzing test scores to tracking sports stats. Marcus's first homework problem uses these quiz scores: 4, 8, 12, 6, 10, 14, 2. Step 1, sort them. 2, 4, 6, 8, 10, 12, 14. Great, 7 values total. Step 2, find Q2, the median. With 7 values, the middle one is the 4th value. That's 8, so Q2 equals 8. Step 3, the lower half is 2, 4, 6. The median of those 3 numbers is 4, so Q1 equals 4. Step 4, the upper half is 10, 12, 14. The median there is 12, so Q3 equals 12. Marcus is already getting it. Now Marcus finishes the problem by finding the IQR. He already knows Q1 is 4 and Q3 is 12. The formula is IQR equals Q3 minus Q1. So that's 12 minus 4, which equals 8. The interquartile range is 8. This means the middle 50% of those quiz scores spans a range of 8 points. Marcus circles his answer and pumps his fist. He just solved his first IQR problem. See? That wasn't scary at all. Here's where some students get tripped up. What if you have an even number of data values? There's no single middle number. Don't panic. When that happens, Q2 is the average of the 2 middle values. Add them together and divide by 2. Then for Q1 and Q3, you split the data into 2 equal halves. Don't include those middle values and find the median of each half. It's like dealing cards into 2 equal piles. Once you know the trick, even-numbered data sets are totally manageable. Marcus's next problem, basketball points scored over 8 games: 15, 22, 9, 31, 18, 27, 11, 24. Step 1, sort them. 9, 11, 15, 18, 22, 24, 27, 31. 8 values, even number. Step 2, find Q2. The 2 middle values are the 4th and 5th, 18 and 22. Average them. 18 plus 22 equals 40, divided by 2 equals 20. So Q2 equals 20. Step 3. Lower half is 9, 11, 15, 18. The median is between 11 and 15. 11 plus 15 equals 26, divided by 2 equals 13. So Q1 equals 13. Step 4. Upper half is 22, 24, 27, 31. Median is between 24 and 27. 24 plus 27 equals 51, divided by 2 is 25.5. So Q3 equals 25.5. Now Marcus can find the IQR for the basketball scores. Q1 is 13, Q3 is 25.5. Plug into the formula. IQR equals Q3 minus Q1. That's 25.5 minus 13, which equals 12.5. The IQR is 12.5 points. Marcus thinks about what this means. In the middle 50% of his games, the point range spans about 12.5 points. That's actually a useful insight for a coach. Marcus is now starting to see why statisticians love the IQR. Here's a question. Why do statisticians bother with IQR if we already have the range? Great question. Imagine your class took a test and everyone scored between 70 and 90, except one student who scored 20. The range would be 90 minus 20 equals 70, which makes it seem like scores were super spread out. But the IQR would ignore that one outlier and give you a much more accurate picture of how most students really did. IQR focuses on the middle 50%, the typical data, and that makes it way more reliable. Let's see this in action with a fun example Marcus finds on his homework. Candy pieces collected at Halloween: 45, 52, 48, 50, 47, 51, 3. Sorted: 3, 45, 47, 48, 50, 51, 52. 7 values, so the middle, the fourth value, is Q2 equals 48. Lower half is 3, 45, 47. Q1 equals 45. Upper half is 50, 51, 52. Q3 equals 51. Now the range. 52 minus 3 equals 49. That seems huge. But the IQR. 51 minus 45 equals 6. The IQR of just 6 tells the real story. Most kids got pretty similar amounts of candy. That 3 was just one unlucky kid. One more problem. Let's make sure you've totally got this. Dataset 33, 21, 15, 28, 19, 35, 25, 10. Step 1, sort. 10, 15, 19, 21, 25, 28, 33, 35. 8 values. Even. Step 2, Q2. The two middle values are the fourth and fifth. That's 21 and 25. Average, 21 plus 25 equals 46. Divided by 2 equals 23. Q2 equals 23. Step 3, Q1. Lower half is 10, 15, 19, 21. Two middle values, 15 and 19. Average, 15 plus 19 equals 34. Divided by 2 equals 17. Q1 equals 17. Step 4, Q3. Upper half is 25, 28, 33, 35. Two middle values, 28 and 33. Average, 28 plus 33 equals 61. Divided by 2 equals 30.5. Q3 equals 30.5. Finally, IQR equals 30.5 minus 17 equals 13.5. Boom! Marcus just realized something. Quartiles aren't just a homework topic. They show up everywhere. Box plots, which you'll use in statistics class, are built entirely from Q1, Q2, and Q3. When your doctor checks if you're at a healthy height or weight, they use percentiles, which are related to quartiles. The NBA uses statistical spread to evaluate player consistency. Even your teachers look at IQR to understand how your class performed on a test. You're not just learning math, you're learning to think like a data scientist. Remember when Marcus stared at that homework, totally lost? Look at him now. He can sort a data set, find Q1, Q2, and Q3, and calculate the IQR without breaking a sweat. And you can too. Here's the whole game plan one more time. Sort your data, find the median for Q2, find the medians of each half for Q1 and Q3, then subtract Q1 from Q3 for the IQR. 4 steps, 1 formula, endless data sets you can handle. Parents and teachers, this is a fantastic concept to practice with real data from everyday life. You've absolutely got this. Now go show your homework.